So our interest is to do the volume up and volume down kind of things. Why I have taken TV remote control as an example, where every one of us can able to understand and we can able to experiment it. That's why TV remote control. Similar to this, when you go to the petrol bank, 100 rupees petrol means they are also doing that. Air filling means they are also doing that. So wherever there is a 7-segment display and input requirement, this can be customized to the corresponding application. But the principle behind this, that is what we are going to discuss now. So if it is volume up and volume down, when I press the button, some variable need to get incremented. So we have to use some variable. Say for example, unsigned character, somewhere in the fourth line, unsigned character C. Say for example, C is a variable, unsigned character C. So what to do? S speed up equal to P2.0, down equal to P2.3. Same, instead of LIS, now we can replace it with up and down, something like that. So 2.0 represents volume up, say for example, and 2.3 represents volume down, say for example. So for that we have to write some two if statements. One if statement for up, another if statement for down. Let us do that inside the while loop. So if up equal to 0, very simple. If up equal to 0, C equal to C plus 1. If up equal to 0, C equal to C plus 1, and port 0 equal to array of C. Then the other two lines are not necessary. That is 19th and 20th line is not necessary. Say C equal to C plus 1, P not equal to array of C, then delay of 50,000, then down equal to 0, P not equal to, C equal to C minus 1. If we press the down key means the C variable has to decrement, so C equal to C minus 1, P not equal to array of C, delay of 50,000. That's all. So this has one mistake. At this moment you may not be able to identify that mistake, but I will demonstrate that mistake and then we'll go back. Okay. So but let us do it, right? So compile, build, download. We can debug it and check in the software, then we can check it in the hardware, right? So in the software, there is something like port 0 and port 2. In the software, we have port 0 and port 2, and when you have to run the code first. So the code is running now. So it is keep on checking two if statements. So it is keep on checking two if statements, and both are 1. So nothing is happening in port 0. So let us make P2.0 as 0. You can see quickly the value will keep on incrementing. Is it incrementing? Just keep on incrementing. So when you make P2.3 as 0, when you make P2.3 as 0, by making 2.0 as 1 and then P2.3 as 0, it has to decrement. Okay, let us assume in the simulation it is decrementing. So our code is working fine. Let us download and check in the hardware. Let us see how fast it works. So it is getting downloaded. 1, 2, 3, 4, 5, 6, 7, 8, 4. Decrement switch 7, 6, 5, 4, 3, 2, 1, 4. 0. Already here, very important thing. Please listen. It's very important. Look at that screen. Now it is 0. We are trying to increment. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then mistake is going to happen. 10. You see 7-segment display fails. 11 fails. 12 fails. 13 fails. Justifies up to 0 to 9. BCD as well as binary both are same. Up to 0 to 9, both BCD and binary both are same. Hence, BCD to 7-segment code conversion works up to 9. Up to 9 means what? The variable C. Up to 9 it works. When the variable C becomes A, C will become A now. For A 1010 we don't have anything, right? So it is showing some error. So we have done a code for BCD to 7 segment through this code. What is missing here? Binary to BCD is missing here. What do you mean by binary to BCD? We have to make that hexadecimal number into ones, tens, hundreds. Because in a byte, we can accommodate 255. So ones, tens, and hundreds, that has to be done in the code. This is how we have to understand, right? So the purpose of code conversion, I'm visualizing it now, I'm justifying it now. So how to do the code conversion? In the variable ones, tens, hundreds. Unsigned character C இருக்கிறது பக்கத்துல ones, tens, hundreds. ONES, tens, HUND மட்டும் போட போதும். Ones, tens, HUND. And அப்படி வச்சுக்கலாமா? HUNDS, okay. Ones, tens, hundreds. So, how to convert binary value to BCD value? Ones equal to C குள்ள கொடுங்க if இல்லைன்னா while குள்ள போங்க. while குள்ள வேற 14வது லைன் நம்ம ஏதோ டைப் பண்ண போறோம். HUND 100 equal to what? C by 100. If the C value is FF, say for example C value is FF, which is 255, FF divided by 100, what will be the quotient? 2. So hundreds will be 2. Very simple. We have converted binary to BCD. So 100, 10, 100, 1000, ones, tens, hundreds, thousand. So we have got hundreds by dividing the C variable by 100. So what will be the remainder? 55. How to do the remainder in the C programming? You have to create one temporary variable. Something like அங்க போனா ஒரு hundreds comma TEMP கொடுக்கலாம். சும்மா temp. ஒரு in between ஒரு temporary variable. Some temp னு வச்சுக்கலாம். temp equal to remainder வரைக்கும் என்ன பண்றது? Modulus. temp equal to C percentage 10, 100. Am I right? temp equal to C percentage 100. That means 255 divided by 100. The quotient is 2, remainder is 55. So temp will have 55. So now what? 10 is equal to temp by 10. Very simple. 10 is equal to temp by 10. 1 is equal to temp percentage 10. So binary to BCD code conversion, we have done just like that in C programming. Now this is software. In the hardware, we have an intelligence only to interface one 7-segment display. The software, we have an intelligence to display interface only one 7-segment display. Even though we have tens and hundreds, as of now we do not know how to use the 10 segment and 100 segment in a 7-segment display. So for time being, forget about hundreds, forget about tens, let us have ones. We not equal to array of ones. Ones கண்டிப்பா என்ன இருக்கும்? 0 to 9 மட்டும் தான் இருக்கும். நீங்க இன்கிரிமெண்ட் பண்ணிட்டே வரீங்க. C equal to C plus 1. C will become A. A by 10 is quotient 1. Remainder 0. So ones will be 0. So ones always will become 0 to 9. Hope you understand what I am trying to say. But in Tail there are so many other facilities to monitor this variables also. So let me tell that to monitor the variables, what to do with Tail IDE here is, there is one watch window. Right hand side. This is watch window. Just hold it, right? Just let it visible, watch window. This is watch window. There is something like watch window. Gandhi Tata கண்ணாடி போட்டிருக்கிற மாதிரி ஒரு கண்ணாடி இருக்குது. கண்ணாடியில் தான் வாட்ச் பண்றது மாதிரி கண்ணாடி symbol, watch window. So here we can enter our expression what need to be watched. We are interested to see the variable C. So enter expression. Here you click and see, enter. So the value of C is 0, 0. It is a character variable. Very simple. And we are interested to see ones, tens, hundreds, and temp. So ones, tens, and HUND, hundreds, and temp. Ones, tens, hundreds, and temp. So this is, if this is FF means this will become 255. And this is the temporary variable. Something like that. It's very interesting, right? So now you can run this code in the simulator. You run this code, and as usual, P2.0, just press one by one. You just keep on pressing. So just keep on incrementing, right? 100, 200, 0, 100, 200, 0. Because it is a character variable, quickly it is running. Okay. So to check means here you can keep one breakpoint somewhere. Okay, you can keep on breakpoint. Now it is 29. Now it is 29. So 1e is your C variable. By converting 1e into its equivalent decimal number, we are getting 29. 1e is something like 29. Then single step. So once again run because it is breakpoint. Then 30. 1f is 30. Again run 20, 31. 32, 33, 34, 35, 36, 37, etc. Like that it goes on. So there is something like watch window. We can make use of this watch window to look at what will be the content of the variables internally while developing the code for a particular application. As told, Kail is more powerful tool. Even 1 crore rupees projects can also be done just like that with Kail IDE. You are doing it for just blinking of an LED. Even very complex applications are developed just like that with Kail IDE. That much powerful tool it is. So slowly we are entering into all the facilities, right? Okay. So this is how you can visualize. Now you have visualized it and we are able to justify that. So 2 code conversions was happened. Yesterday itself we have discussed several times. So whenever there is a 7-segment display, it will undergo 2 code conversions. Then only 7-segment display will display. One code conversion is binary to BCD. Another code conversion is BCD to 7-segment. By using 1 is equal to 10 is equal to 100 is equal to by 100 by percentage 100, we have converted the given binary, that is C is in binary. That binary content of C is converted to 1s, 10s, 100s, which is a BCD value. So this is again converted to the 7-segment code by lookup table. A of 0 means 0 equivalent of 7-segment code, which is 3F will go to the port 0. A of 1 means 1 equivalent of 7-segment code from the array will go to the port 0. So in that lookup table, we have converted BCD to 7-segment code. So binary to BCD will happen. BCD to 7-segment was happen. It works fine. Okay. So now we can download and check. After 9, you cannot expect unwanted segments. We can expect 0 only. We'll check that. That will be very interesting because we are sending out only once. After understanding how to interface second 7-segment display and third 7-segment display, very well we can display up to 255. But right now we can display from 0 to 9. But C variable will increment. But here we are not able to see the 10, 11, 12 and all. What do you mean by emulation? Testing both the hardware and software simultaneously is emulation. That needs some more powerful tool. So as of now, both are isolated. So simulation is different, hardware setup is different. So they are testing it. So 0, now we are incrementing 1, 2, 3, 4, 5, 6, 7, 8, and after 9, again you will get 0, which is 10. Okay. So when you keep on pressing, press and hold it. Press and hold means it will be the same function. So it will keep on incrementing. Fortunately, there is a delay of 50,000. So every 50,000 delay, the program execution come to that statement. Every time C equal to C++, something like you pressing and holding the volume up button. Sometimes it won't increase the volume continuously, means you press and hold the volume up button. So the volume will keep on increasing. So let us decrement the volume. Array of ones, that's all. So edit and download means you can do the decrement. So now we are very much comfortable with switch interface, LED interface, 7-segment interface. So now we are very much comfortable with 7-segment, switch interface, LED interface, integrating all the 3 together. Okay. Okay, let us do the decrement part. Decrement and decrement. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 cover up correct sorry 9. 9 ring correct 6, 7. 9 ring correct 8. Decrement key. When you press the decrement key, it is getting decremented. When you press the increment key, increment 1, 2, 3, 4, 5, 6, 7, 8, 9. Decrement key -1, -2, -3, -4. That is 10. So incrementing 1, 2, 3, 4, 5, 6, 7, 8, 9. Decrementing 9, 8, 7, 5, 6, 4, 3, 2, 1.